Yeah, in this video, I'm going to discuss about the elimination reactions under the types of organic reactions. In my previous videos, I've already done with addition reactions and substitution reactions. Now, let's see this elimination reactions in detail. So, the elimination reactions are the reactions in which, as the name suggests, the atoms or the groups are removed from the molecule. So, the the reactions which involve the removal of the atoms or the groups are called as the elimination reactions. Let's see this example now from this alkyl halide. Uh, the the groups are removed or the atoms are removed from, let's name this as 1 and 2, from the C1 and C2 carbon atoms. Here from the C1, this halide group is removed, that is X, and from the C2 carbon atom, this H is removed, resulting in the formation of an alkene here. These are called as 1-2 eliminations because the atoms are removed or the groups are removed from the adjacent carbon atoms. So the reactions in which the atoms or the groups are removed from the adjacent carbon atoms are called as 1-2 eliminations or beta elimination reactions. So generally the reactions are of this type, elimination reactions, that are the beta elimination reactions in which the atoms or the groups are removed from the adjacent carbon atoms. One is the proton, here we can see H plus, and the other one is a nucleophile which is removed here. So one is a proton and the other one is a nucleophile, resulting in the formation of a new pi bond in the product here. In the product, this new pi bond is formed here. This is, we can see this is a new pi bond which is formed by the removal of two atoms from the adjacent carbon atoms. One is a proton and the other one is a nucleophile. So the name elimination reactions. So these are just opposite to that of the addition reactions. So in the addition reactions, the atoms or the groups are added to the molecule to the pi bond. Here, atoms or groups are added to the C1, C2 carbon atoms, resulting in the formation of an saturated compound in the addition reactions. So this is just the opposite to that of the addition reactions, resulting in the formation of an unsaturated compound, that's resulting in the formation of a new pi bond. In the addition reactions, is just the opposite is formed, where the new sigma bonds are formed. See, what are these? These are what are elimination reactions. Now, let's see what are these types of elimination reactions depending upon when this bond breakage is occurring, when the CH and CNU bond breaking, depending upon the timing and depending upon the which step these bond breakage is occurring, their reactions of these eliminations are divided into three types. First one is E2, that is elimination bimolecular. E1, that is elimination unimolecular, and the third one is even CB mechanism, depending upon the HC and CNU bond breaking processes. Yeah, let's see now this E2 elimination bimolecular in detail now. So when we look at this mechanism, this, as the name suggests, E2, we have already seen this in SN2, where SN2 is substitution nucleophilic bimolecular. In the same way, E2 means elimination bimolecular. This 2 means two molecules are involved in the rate determining step of the reaction. So this is a single step reaction, that means it's a concerted reaction where the reaction is completed in a single step and no further steps are needed for the completion of the reaction and proceeding through the transition state. So the elimination is occurring in a single step. So the name bimolecular, so it's a concerted reaction where the CH bond and the CNU bond breaking occurs in the single step. So the base here is pulling out a proton, is abstracts a proton, and at the same time the nucleophile is leaving. So this can be seen in the transition state like this, where the bond breakage, CH bond breakage and CNU bond breakage are occurring in the single step, which is proceeding to the transition state. The transition state is the one which cannot be isolated like an intermediate, and resulting in the formation of an alkene here, and this is a nucleophile. plus the nucleophile and plus this HP. Yes, base is abstracting a proton, and the nucleophile is leaving the molecule at the same time. So occurring through a single step, proceeding through a transition state, and the reaction is a bimolecular reaction where the rate of the reaction is dependent upon the concentration of both the reacting molecules, that is the concentration of the um, alkyl halide and also the base which is added here. So the name so the name E2, that is elimination by molecular reaction. Yes, this is the base, right? So the rate of the reaction is dependent upon both the concentrations of the alkyl halide and also the added base here. So let's look at this with the help of an example here, that is dehydrohalogenation of alkyl halides. Let's see this. So let's see this, take this ethyl bromide here, dehydrohalogenation of ethyl bromide, where the base which is added is KOH. This OH minus will come and abstract the proton from this ethyl bromide, and the Br minus is also, yeah, this is a dotted line here, leaving the molecule at the same time in the single step, resulting in the formation of water plus ethene, and this Br minus is leaving nucleophile here. So the nucleophile is leaving, and also the CH bond breakage is occurring at the same time in the single step reaction here. In the single step, so it is called as an E2 reaction, the elimination bimolecular reaction. Yes, where the rate of the reaction is dependent upon the concentration of both the ethyl bromide and the attacking base, that is the KOH here. So let's look at a few more examples here. Yeah, let's look at this dehydration of ethanol to alkene, where this H and this OH is removed from the adjacent carbon atoms, that is a beta elimination reaction. So 1,2 elimination reactions resulting in the formation of ethene and water here. And the dehydrohalogenation of propyl bromide, let's see this. This OH minus is abstracting a proton from this carbon atom, and the Br minus, that's the leaving nucleophile, is leaving from this carbon atom, two different carbon atoms, resulting in the formation of double bond here. Propene is being formed here, and Br minus, that's the leaving nucleophile here. And so the name E2, that is elimination bimolecular, and yes, single step reaction. Now let's see this E1, that is elimination unimolecular reaction, where the rate of the reaction is dependent, as the name suggests, only on the concentration of the alkyl halide and not on the added base here. So it's dependent only purely on the concentration of the alkyl halide here on the substrate, that is alkyl halide. And here it's a non-concerted reaction. That means it is not occurring in the single step, it's taking many steps. It's a multi-step reaction, and CH and CNU bonds are broken separately in two different steps. So let's see what are these two steps, how it is proceeding through a transition state or as an intermediate. Let's see this. The first one is the KOH is, yeah, K plus and OH minus, this base added here, and OH minus here, yeah, is the first step here where the bromide is leaving, that is Br minus CNU bond breakage occurs in the first step. The first step is CNU bond breakage is occurring in the first step, unlike the E2 reaction where the CNU bond breakage and CH bond breakage are occurring in a single step. Unlike that, here the CNU bond breakage is occurring in the first step, resulting in the formation of an carbocation intermediate here. This is the intermediate and not the transition state. So this is the difference in between the E2 and E1 reactions here. And this is a slow and the rate determining step of the reaction. So the rate of the reaction, as I said, is dependent solely on the concentration of only the alkyl halide and not on the concentration of alkyl halide. Yeah, and not on the constant alkyl halide. Let's write it here. Right. Yeah. and not on the concentration of attacking KOH here. So the name E1. So E1 is elimination unimolecular, where the rate of the reaction is dependent only on the concentration of this alkyl halide and not on the new KOH here. This is the slow and the rate determining step of the reaction. And this carbocation, which is formed in the first step, is then in the second step. Now this is attacked by a water molecule, that is OH minus, is then abstracts a proton from the second carbon atom. This is C1 and C2 carbon atom, and resulting in the formation of an alkene here. That's a product we wanted. So there's a fast reaction, there's a fast step, and so this is not the rate determining step or the rate limiting step of the reaction. So the reaction is proceeding through an intermediate here. So the reaction is proceeding to two steps. The first step is a carbocation formation with the C-NU bond breakage, and the second step is the CH bond breakage, resulting in the formation of a double bond or a pi bond here, resulting in the formation of a product that is an alkene. So let's see this with the help of an example, that is dehydrobromination of tertiary butyl bromide. So one more thing, this occurs in tertiary alkyl halides. More in tertiary alkyl halides is because the intermediate which is formed here is stabilized by means of, this is CH3 here, electron releasing groups here. So this is electron releasing group. So the intermediate which is formed here can be stabilized by these three these three methyl groups here. So tertiary alkyl halides react by E1 mechanism, and primary alkyl halides react by E2 mechanism, because the transitions, it proceeds by the transition state, and for the tertiary alkyl halides to proceed through E2 reaction, there is a lot of steric hindrance. So in the transition state, there is a lot of steric hindrance. So it cannot proceed through E2 mechanism. So the tertiary alkyl halides proceeds through this E1 mechanism, because the intermediate, the carbocation which is formed, is stabilized by these methyl groups here by means of its electron donating capacity. So the BR, the CNU bond breakage here, that is BR is a nucleophile here, that's leaving group. So CBr bond breakage is occurring here in the first step, resulting in the formation of carbocation, and the carbocation in the next step is attacked by this OH minus, as a nucleophile we are adding. So resulting in the formation of a double bond here. This CH bond breakage is occurring in the second step. So this Br minus is taking away this OH minus is taking away or is abstracting the proton from this, resulting in the formation of an alkene here. Yes. Now let's see the third mechanism, that is even CB mechanism, where it means that's elimination unimolecular conjugate base mechanism. So again, now let's see the mechanism of this now. Here, even CB mechanism, in this it's proceeding through two steps again here, where in the first step, CH bond breakage is occurring. Unlike this E1 mechanism, here it's CH, that CNU bond breakage is occurring in the first step. This CH bond breakage is occurring in the first step, where the base will come and abstract the proton in the first step itself, resulting in the formation of an carbanion here. This is a carbanion which is negatively charged here, carbanion. Yes, the negatively charged carbon species is a carbanion. We know this here. So the mechanism is also called as carbanion mechanism. So even CB mechanism is also called as carbanion mechanism, because it is proceeding through the carbanion intermediate here. Yes, carbanion intermediate is being formed here. This is a carbanion intermediate. In the even, we have seen the carbocation intermediate. Here is a carbanion intermediate. So carbanions are stabilized by electron withdrawing groups here. So there it was electron releasing groups. Now here it is electron withdrawing groups. Stabilize the carbanion here. Now in the second step, from this carbanion, the nucleophile, hence it is, then this carbanion loses a nucleophile, that is CNU bond breakage is occurring in the second step, resulting in the formation of an alkene. So this is the difference in between the E1 and E1 CB mechanisms. And yeah, let's see let's compare them, that E1, E2 and E1 CB mechanisms in detail now. So yes, when we look at this E1 mechanism, as the name suggests, it's a unimolecular. So the unimolecular, and depends upon the rate of the reaction is dependent only upon the concentration of an alkyl halide or the substrate. So it is proceeding in two steps. That is the in the first step, the CNU bond breakage is occurring. That's the leaving group breaks. And in the second step, CH bond breaks, resulting in the formation of a pi bond. See, so first step, this is breaking off, and the second step, this is breaking off, resulting in the formation of a pi bond here. And next one is E2. There's a bimolecular here. As the name suggests, the rate of the reaction is dependent both on the concentration of the alkyl halide and also the nucleophile that is added nucleophile, and it's a one-step mechanism. That's a concerted reaction. That's a single-step reaction. And CH bond breakage, pi bond formation, and CNU breaks all at the same time, proceeding through a transition state here. Here it is, carbocation intermediate is formed. Yes, carbocation intermediate. No intermediate, only transition state here. And even CP mechanism is also by two steps, as just the reverse of that E1 here. The first step, CH bond breakage. Here, CH bond breakage. In the second step, CNU bond breakage. There's a leaving group, CLG, that is a leaving group here, breaks, resulting in the formation of a pi bond here. So this is shown pictographically here. And the carbanion intermediate proceeds to a carbanion intermediate. Yes, and the carbocation is stabilized by electron donating groups, and carbanion is stabilized by electron withdrawing groups.